sir.
Everyone is good?
Yes.
All right. Any doubts from the last class? All clear about inverse trigonometric function differentiation? Right, Krishna, Ronaldo?
Yes, sir.
All right, Ishan?
Sir, did you check the assignment?
No, I have not checked the assignment. You mean the test paper, right?
No, sir. Assignments, sir.
Assignments? No, I have not checked that yet. All right. In the next class, we'll be getting the like checked papers. Do you have any doubts in that, Krishna? In the assignments?
I have a doubt in the assignment, sir.
All right.
This question only, the one that's written above. The
Give me
answer
a
is
second.
different.
Just give me a second. All right. Let me get the assignment. Which question you are saying? You are talking about assignment 3, right? Which assignment you guys are talking about?
So the last assignment.
No, I don't know actually which assignment this.
Differentiation, assignment 1.
The assignment
All right.
one.
All right, assignment 1. Which question?
7th question.
All right. 2 under root cot x square. This one?
Yes, sir, but the answer is different. In the second page, there are answers.
All right. This question we did in the last class also. Let's see what the answer is first. What we get. This is 2 cot x square under root 2x. Then cot is square x into 2x. Right? This answer you are getting?
Yes, I got this answer.
All right. Then if we can convert this, we can match the answer. So this is minus 2x upon sine square x, right? This is 1 upon sine square x. If we write, all right, I think the mistake cos in here. All right, the mistake cos, because if we have to write this, no, this answer is wrong. You cannot change this into this. This will be cot, right? If you change this, this will be cos x square, and we'll get under root sine x square. So this has to be cos in here, or we can do this minus 2x. See, this under root sine x square and this, if we cancel out, sorry, this is this, then what will we get here? Any ideas what we can write it if we cancel this thing out? If we cancel this out, what we will get? Anybody?
So
If you
sine x square.
Sine?
So x first.
Krishna, your voice is breaking. Ronaldo, how we can cancel this out? This is sine x square to the power half, and in the denominator we have sine x square to the power 2. So what will the remaining
Sir,
power here?
root sine x square.
Right. So we can write this simply sine x square to the power 3 by 2. Right? Kulsum, this thing is clear?
Yes, sir.
All right. So this is, now I can write this as this. Be careful about this, under root sine x square into how much will remain here? if I separate this with under root sine x square, how much power will remain here? If I take half power from out of this, how much power will remain?
2/2.
2/2. So what is 2/2?
1.
1. So sine x square will remain, right? And this is cos x square. Now these things we can multiply together. So this is 2x sine x square under root sine x square cos x square. All right. Now look at the question. I mean the answer. I also missed this thing. They have put under root sine 2x square, right? So half angle formula. If you open this, you will get 2 sine x square cos x square, right, Kulsum?
Yes, sir.
So we have this. So if you can multiply 2 here and divide by 2, we can divide by root 2. We can write this as this, right, Kulsum?
Yes.
Then this root 2 will go to numerator, and you will get minus 2 root 2x sine x square under root sine 2x square. All right. So yes, you can get this answer, but you have to do a lot of calculation. But it's okay if you leave the answer in quad, no issues, until and unless they tell you to prove this is equals to this. All right, you can leave this answer in this form, or you can convert this into sine and cos. You don't have to write this in this format as such. All right, Kulsum?
Yes, sir, I got it.
Yeah, but if they ask you to prove, then you have to think about all of this, how to convert. I hope everyone is clear about this. Krishna? Krishna, your voice is not coming if you are saying anything. All right.
Sir, am I audible now?
Yes, now you are audible. All right. So let's start with the question. Very easy question. And anyone who missed the last 2 classes, please get the lectures. All right. So that you can watch what we did in the last 2 class. If y equals to cos x minus sin x upon cos x plus sin x, prove that dy by dx plus y square plus 1 equals to 0. All right. I'll give you a few minutes to solve this.
Sir, can you help solving this question?
All right. Anybody has solved this? Ronaldo, Said, Shikani, Kulsum.
Sir, I did try but couldn't complete it.
I got dy by dx.
All right. So you can just put the value here. You'll find the answer, right?
Okay.
So how we can find dy by dx? Krishna, just apply this u by v form. What is the formula? Differentiation of a function upon function. Krishna, what is the formula for this? Differentiation of u by v.
v dash u minus u dash v by v square.
V dash u minus u dash v, or is it the opposite? V u dash minus u v dash. Which one is it? 1 or 2? Kulsum, which one is it?
So it's the second one.
Second one, right? So cos x plus sin x into differentiation of numerator. So this cos x is minus sin x, and minus sin x will be minus cos x. All right. Minus of cos x minus sin x into differentiation of denominator, which is minus sin x plus cos x, whole divided by sin x plus cos x whole square. All right. No issues here. Krishna? Krishna, your voice is breaking again.
Sir, can you hear me now?
Yes.
So I'm
No, your voice again. Your voice is gone. Anybody else has like any doubts in this step?
Sir, I didn't use this method. I
Which
simplified
method?
it first and then from dy by
Alright.
dx.
Yeah, that's also cool. No issues. I am more of a like simplistic guy. Like I just differentiate it. Like how did you simplify? Like divided by cos x and all.
Yes, divide by cos x and find tan x.
All right. That you can also do, right, Krishna? Are you seeing that also? Like solving for y, that
okay,
means
sir.
you are,
Yes, sir.
yeah, you can divide by cos x, then this will be tan a minus b formula, and do that. In this method, you can take this negative out. So this will be minus of sin x plus cos x whole square minus, see, this is also cos x minus sin x. So cos x minus sin x whole square upon sin x plus cos x whole square. You can take again negative sign out, simplify this. You'll get a very simple answer. Put that in this equation. Put the value of y square plus 1 equals to 0. You'll automatically get the answer. All right, Krishna?
Yes, sir.
All right. And give me guys 10 minutes. Actually, my like earphones have run out of like battery. All right. And so sorry for that. But I have to charge for 5 to 10 minutes. All right. Until then, you guys try to solve this and revise the previous things. All right.
Okay, sir.
Everyone, cool.
Yes, sir.
All right. All right, you have solved this. Everyone is in the class or not?
Yes, sir.
All right, so this question is done.
Yes, sir.
All right, let's move on. Logarithmic differentiation. How many of you know what is log function? Any of you know what is log function? Ishan? Your voice is not coming through. All right, Ronaldo, what is log function? All right, Syed? Kulsum?
Sir, it's the opposite of exponentiation.
Absolutely right. It's the opposite of exponential functions. If I write 100 equals to 10 raised to the power 2, what I can write in log? Log 100 to the base 10 equals to 2, right?
Yes.
This thing is clear? Yes. So if anyone doesn't know how to convert these things, if you have z equals to x raised to the power y, all right, and if you have to take log both sides, then what happens is this thing, what happens, who can tell me what will be log here? What I can write in log?
X.
Log x, and this.
No, sir. Log Z to the base X is equal to Y.
Absolutely right. All right. So the final answer comes as the logarithm of this number. This comes as the base. The power comes as the answer to the log function. All right. And if you have to change or inverse this, then just push this x this side. This becomes the exponent form. All right. This is clear, Ishan? You are going to need a lot of log in this chapter and in the coming chapters. All right. So there are generally two types of log in this world that we study: common logarithm and natural logarithm. Common logarithm has a base of 10, right? If you write log x to the base 10, this will be called common logarithm. In natural log has a base of e, right? E is a constant number. So if you write log x base e, this will be a natural log. All right. These are just the names. And if in NCRT you don't see anywhere written the base is not written. That means this is natural log. This thing is clear, because NCRT will not write bases every time. All right. Even you don't have to write bases every time. Just write log x, log y, and this is understood that the base is e here. All right. You can write it down. Then we'll go through the properties.
Can you hear me now?
Your voice is breaking again. Just now you can just type it out, whatever you are saying. All right, done writing this, everyone?
Done, sir.
All right. A few properties of log which is very necessary. First property is product rule. If you have two numbers multiplied in logarithm, then we can write this as log m plus log n. All right. Otherwise, you can look at it like this. If two numbers are added with the same base, right? Bases should be same. Then you can multiply these two numbers and write a single log function. This is clear. An example of this is if we write log 2 into 3, and this will be equal to log 2 plus log 3. This is clear. Everyone, is this clear? Ishan, Ronaldo, Shikani?
Yes, sir.
All right. Similarly, we have another rule, another property, that is division rule. If you have two numbers divided like this, then you can write log m minus log n. All right. Or if you have two log function in subtraction, you can divide those number and write a single log function. For example, log 2 upon 3 is log 2 minus log 3. All right. Note it down if this is clear. Done, everyone? This is clear.
Yes.
All right. Now your doubts are clear?
So can you hear me now?
No, your voice is still breaking. All right. So exponential rule. If you have log m to the power n, all right, and this is not log to the power m, this number has the power n, then you can take this power outside of log. All right, for an example, log 2 to the power 3 is equals to 3 log 2. This is clear. And don't confuse this with log 2 whole power 2. This 2 cannot get outside. If the base, oh sorry, the exponent has power, then you can take the power outside. Is it clear, everyone? Today everyone is very low energy, it seems. Ishan, your voice is not through. Ronaldo, Kulsum, Shikani, this is clear.
Yes, sir.
Yes, sir.
All right. Fourth property is change of base. If you have log m to the base p, you can write this as log m to the base a upon log b to the base a. All right, you have to keep the base constant with whatever base you want. You can write this as this log m to the base a, log b to the base a. Suppose you have log 3 to the base 2. This you can write log 3 to the base 10 upon log 2 to the base 10. All right, this is clear. Everyone, is this clear?
Yes, sir.
Yes, sir.
All right, note it down. All right. Two more properties. Base switch rule. You can switch the basis of logarithm. If you have log m base n, this is 1 upon log n base m. For an example, log 2 base 3, we can write 1 upon log 3 base 2. All right, very simple. 6-1. Who can tell me what will be log a base a? What is the answer of this? Can anyone tell me what will be this answer? 1. Absolutely right. Because what is the power of this a so that we can get a? So a raised to the power 1 will be a. So the answer will be 1. So no matter what, if you find log 10 base 10, that will be 1. Log 1 base a. What is the answer for this?
0.
0. Absolutely right. Because only a raised to the power 0 will be 1. Otherwise, this will never be 1. So log 1 is always 0. All right. All the properties are clear, Shikani?
Yes, sir.
All right. Kulsum, Said, this is clear?
Yes, sir.
Yes, sir.
Please note down properties, then we'll solve some questions. All right. Now, what kind of questions do we need to solve in logarithm? They will not give you log x, log y. You have to think about where to apply logarithm, then solve the question. Suppose I give you y equals to sine x, sine 3x, and sine 5x. These are all in multiplication. And if I ask you to differentiate, how we can differentiate this? Let's assume this is u, this is v, then apply u into v formula, right? Then when differentiating this one, again we have to use product rule, right? So you have
Yes,
to
sir.
use the product rule 2 times, and this will be very lengthy. And the beautiful thing about logarithm is it changes multiplication into addition. So if you take log both sides, this is log of sine x, sine 3x, sine 5x, right? We have 3 numbers in multiplication. So if we apply the property of log product rule, this will be log of sine x plus log of sine 3x plus log of sine 5x. So a question where we had the function as multiplication of 3 function, now we have addition of 3 function. And obviously addition differentiation is very easy compared to multiplication, right everyone? This thing is clear? Ronaldo,
Yes, sir.
Shani,
Yes.
all right. So whenever you see 2 or more functions, not in 2 functions, more than 2 functions multiplied or divided and so on, please use log function. Now we can differentiate. Differentiation of this will be d log y dx, and differentiation of log of sine x plus differentiation of log of sine 3x plus differentiation of log sine 5x upon dx. Now what is the differentiation of log y with respect to x?
One by y.
1 by y. There is no dy by dx.
Yes, sir. Divided by dx.
Right. Side, you missed last 2 classes, right?
No, sir. Last one class.
Last 1 class. That is why, right? So log y 1 upon y dy by dx. Why so? D log y upon dy we can differentiate with respect to y, then dy by dx. All right. So this is the reason why we have to multiply dy by dx here, and this is differentiation of log of sine x. I hope you guys remember chain rule.
Yes, sir.
So what will be the answer of log of sine x differentiation?
So 1 by cos x.
1 by cos x. No. Think again.
So 1 by sin x into cos x.
Absolutely right. Everyone, you got how this is solved? Kulsum?
Yes, sir.
So how we can do this? This is differentiation of log of sine x. First we can differentiate with respect to sine x, then differentiation of sine x with respect to x, plus again we have to use chain rule here, sine 3x. So differentiation of log sine 3x with respect to sine 3x into differentiation of sine 3x with respect to 3x, then differentiation of 3x with respect to x. Krishna, this is clear?
Yes, sir.
And the last one is differentiation of log of sine 5x, differentiation of sine 5x. I hope you are getting this. Very lengthy question, I know, but what can we do? So this will be 1 upon y dy by dx equals to, this is 1 upon sin x into cos x plus 1 upon sin 3x into, this is differentiation of cos 3x into 3 plus 1 upon sin 5x into cos 5x into 5. This thing is clear to everyone? Yes or no? Ishan, Shikani, Ronaldo?
Yes, sir.
All right. So 1 upon y dy by dx. This is cot x plus 3 cot 3x plus 5 cot x. If we can multiply this y to this side and put the value of y, which was sin x, sin 3x, and sin 5x. This will be your final answer. All right. Are we clear about this, everyone?
Yes.
All right. Kulsum, Said, Krishna.
Yes, sir.
Yes, sir.
All right. So let me give you a question to solve. Let's see. Very similar question. Y equals to sin x, sin 4x, and sin 6x. All right. I'll give you 3-4 minutes for this. All right, everyone solve this?
Yes, sir.
All right. Do I have to solve this, or we can go move forward? Anyone has any doubt in this? Ronaldo, this is clear?
Yes, sir.
All right. Ishan, Shikani. Ishan, your voice is not coming through. Please type it out. All right. So I hope you have the answer for this. Next question. Y equals to under root x minus 1, x minus 2 upon x minus 3, x minus 4. All right. Now, this question also you can directly differentiate, but that will be very lengthy. Right. First, you have to look out for under root function, then u upon v, and in this you have to use uv form. Right. Two functions are multiplied, or you have to multiply then differentiate. But again, what we can do, take log both sides. Now this under root is whole power half, right? So you can take this half outside. This thing is clear? Using the exponential rule, this is log x minus 1, x minus 2, x minus 3, x minus 4 whole to the power half. So this half can go outside. Yes or no, everyone?
Yes, sir.
Yes, sir.
All right. Then again, this m into n upon p into q. So you can use the product and division rule again. So this will all be converted into addition and subtraction. And then differentiation of this will be very simple. All right. So please try to solve this one further. This thing is clear or not, what I said? Shikhani, this is clear? No, when solving questions, Shikhani is always silent. Kulsum Said, this is clear?
Yes, sir.
Yes, sir.
All right. So try to solve this one. And I'm putting the earphones on charge again. If you have any doubts, just put in the chat box. I will see. All right, Krishna. See, after this half, we take out outside the log. This is m into n, p into q, right? So if you look at the log properties in the product rule, we can write log m into n as log m plus log n, and this division part is minus of log p plus log q. So all of this can be converted into log m plus log n minus log p minus log q. Is it clear now, Krishna? All right. If you have any doubts, just put in the chat. Anyone solve this? Krishna, Ishan, Kulsum, Saeed, Ronaldo. No one has solved this. You have. All right, Kulsum,
Solving, sir.
solving. All right, Saeed.
Sir, I haven't completed yet.
All right, I'll give you guys 2 more minutes.
Done, sir.
All right. So we can solve this further as log y half log of x minus 1 plus log of x minus 2 minus log of x minus 3 minus log of x minus 4. Now differentiating this. This is 1 upon y dy by dx equals to half of differentiation of log of x minus 1. What will be the differentiation of this function?
1 by x minus 1.
1 by x minus 1 plus this will be 1 by x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4. Now you can take LCM and solve this one further. All right, and multiply this y also to this side, dy by dx y by 2 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon minus 3 x minus 4. All right, I hope this is clear. Krishna.
Yes, sir.
All right, and don't leave like this. You have to take LCM and simplify. Also put the value of y as the question. All right, Ronaldo, this is clear.
Yes, sir.
All right, see, next type of question is yes, who has the doubt? Krishna, were you saying anything?
Yes, sir. Can you hear me?
Yes, now I can hear you. Now you are gone. Like whenever you try to speak something important, your voice breaks. All right, you can type it out. Next type of question you will face is y equals to x raised to the power x. All right, and this is variable to the power variable. If we had x raised to the power 3, we can easily apply that formula, n x n minus 1, right, 3x square. But this formula cannot be applied here because we have variable to the power a variable. If it was constant, then you can use the formula, or a constant raised to the power x. Even then we have a formula, but this is variable to the power variable. In this type of questions also you have to use log function. So taking log both sides, we have log y equals to, this power can come to outside, so this is x log x. Now you can differentiate both sides, and this is u, this is v, u into v form, and you can find the answer. This thing is clear, everyone? Very important part, very important question also. You can star mark this. This thing is clear to everyone? Ishan, Kulsum, Saeed?
Yes, sir.
All right.
Yes, sir.
Then solve this further and tell me the answer what you get. Krishna, your doubt is clear? All right. All right, everyone solve this?
Yes, sir.
Right, what is the answer here? dy by dx is? What is the answer here? Right, y into 1 plus log x. So let's see how we can differentiate. This is 1 upon y dy by dx, and this will be log x, differentiation of x, plus 1 upon x, so 1. dy by dx is y into 1 plus log x, and y is x raised to the power x, so x raised to the power x 1 plus log x. This is the final answer. Everyone is clear about this?
Yes, sir.
All right. Ronaldo, Ishan, Shikani.
Yes, sir.
All right. Next question. So whenever you have variable to the power variable, try to take logarithm and solve. Don't use the formula directly. Next question. Y equals to x minus 3 x square plus 4 whole divided by 3x square plus 4x plus 5 under root. All right. Try to solve this one.
Yeah.
All right, solve this, everyone. All right, no need for me to solve this. Kulsum, Saeed, Ronaldo.
Done, sir.
All right. Next question. Y equals to x raised to the power sin x. Try to solve this one.
Done, sir.
Right. All right. Everyone solve this? Krishna, Saeed, Ronaldo. Ishan. All right. So what we can do, take log both sides. Now we can just differentiate 1 upon y divided by dx equals to this is sin x upon x plus cos x log x. Just multiplying this y to that side, dy by dx equals to y is x raised to the power sin x by x plus cos x log x. Right, this is the answer, everyone. Kulsum,
Yes, sir.
Saeed. All right. Next question. Sin dy by dx if y raised to the power x plus x raised to the power y plus x raised to the power x equals to a raised to the power b. All right, just write down this question. I'll give you a hint how to solve it. Done. Have you written down this question?
Yes, sir.
All right. Now we have learned today this log m n p. This we can convert into addition. But if the question is already in addition, then log cannot do anything, right? We don't have any property for log m plus n plus q. We cannot do anything. So what to do here? If I can assume that let u equals to y raised to the power x, v equals to x raised to the power y and w equals to x raised to the power x, and this question becomes u plus v plus w equals to a raised to the power b, and we have to differentiate this. So differentiating with respect to x on both sides, we have du by dx plus dv by dx plus dw by dx is equal to differentiation of a raised to the power b dx. All right, so this will be du by dx plus dv by dx plus dw by dx equals to 0, right? This is constant and differentiation of constant function is 0. Now what we can do, differentiate this individually, right? Find du by dx from this, dv by dx from this, dw by dx from this, and put the values here, and we can find the question, the answer of this question, dy by dx. This thing is clear or not? Everyone, this is clear what we did here? Krishna, Kulsum, Said, Ronaldo.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. No, Krishna, log method, if you take directly logarithm in this question, then there will be no benefit, right? Because this function is already in addition. But when differentiating this thing, du by dx, you have to take log function, right? Because this is variable to the power variable, again variable to the power variable. So you have to put log when differentiating this. But if you put log directly here, then there will be no benefit to you. First you have to substitute, then differentiate, then put the values. All right, Krishna? All right, then try to find the answer here. Solved it, anyone? Krishna, Kulsum, Said, Ronaldo?
Yes, sir. Done.
Done. All right. Rest of you? All right, Krishna. Let's see. Let's solve this one by one. So we have y raised to the power x. So taking log u equals to x log y. Differentiating 1 upon u du by dx equals to log y plus x upon y divided by dx. Right? U into v form. Differentiation of x is 1. So 1 into log y plus x times differentiation of log y. Differentiation of log y is 1 upon y divided by dx. So du by dx will be u into u means y raised to the power x into log y plus x upon y dy by dx. This thing is clear, everyone? Ishan, this thing is clear? All right. I hope that was yes. And v as x raised to the power y. So taking log again, log v equals to y log x 1 upon v dv by dx equals to differentiation of y is dy by dx log x plus y by x. So dv by dx is v times v is x raised to the power y dy by dx log x plus y upon x. All right. Then w we have x raised to the power x and dw taking log in. We just differentiated this. All right. And I also remembered the answer for this, but let's solve this step by step. Log w is x log x 1 upon w dw by dx equals to differentiation of x is 1, so log x plus differentiation of log x is 1 upon x, so x upon x is 1. So this dw by dx is w times this, so x raised to the power x 1 plus log x. Krishna, this is clear till now? Krishna, this is clear? All right. Now we can put these values in this equation. Suppose this is equation 1. So putting these values in equation 1, we have du by dx is y raised to the power x log y plus x by y dy by dx plus dv by dx. dv by dx we have here. This is x raised to the power y dy by dx log x plus y by x, and dw by dx is x raised to the power x 1 plus log x, and this is equal to 0. From here you can find dy by dx. Take all the terms of dy by dx together. So this is y raised to the power x log y plus y raised to the power x upon y into x divided by dx plus x raised to the power y divided by dx log x plus x raised to the power y upon x plus x raised to the power x plus x raised to the power x log x equals to 0. This term as dy by dx, this term as dy by dx. Keeping this together on this side, send everything to the side. So what we have, dy by dx, if we take common, this will be x y raised to the power xy plus x raised to the power y log x, and everything is that side, taking negative common, y raised to the power x log y plus x raised to the power y x my plus x raised to the power x plus x raised to the power x log x. Now you can divide this to the side. Give me a minute. Yes. So dy by dx will be all of this divided by this. All right. Krishna, Ishan, Ronaldo, this thing is clear.
Yes.
All right. Said, Kulsum, this is clear.
Yes, sir.
All right. See if you can simplify this further. This y can go to this, and this will be x minus 1. Same for this. Doesn't make a lot of difference, but you can type like it looks better. All right. I hope this is clear. If anyone wants, note it down. I'll give you 2 minutes to note it down. This part. Done, everyone? Everyone, this is clear. Kulsum, Said, Krishna, Shikani, Ishan.
Yes, sir.
All right. Next question. Find dy by dx. Oh, the question is x raised to the power sin x, or differentiate sin x to the power x plus sin x to the power cos x. All right. Try to solve this one. And this is whole power x, sin x to whole power x plus sin x whole power cos x. solve this, everyone? Have you solved this? Kulsum, Said, Krishna? Two minutes. All right. All right. So how we can solve this? First, differentiate this. Let u equals to sine x to the power x. So log u will be x log sine x, and this is 1 upon u du by dx equals to differentiation of x is 1, so log of sine x plus x upon sine x into cos x. So du by dx will be equals to du by dx will be equals to u into, that means sine x to the power x into log of sine x plus this is cot x cot x. Now we can take v equals to w equals to sine x to the power cos x. So log w equals to cos x log sine x. So 1 upon w dw upon dx will be equals to differentiation of cos x is minus sine x to log of sine x plus cos x upon sine x into cos x. So dw by dx is sine x to the power cos x into this is, I'm writing this one first. So cos x into cot x minus sin x log of sin x. And just put the values here, you'll get the answer. This thing is clear, everyone? Kulsum, Said, Shikani, Ronaldo, Ishan.
Yes, sir.
All right. So today we did a lot of things, logarithmic differentiation, right? All the parts, all the types of questions. And in the next class, there will be an exam. All right, a test. So shall we keep a test of this chapter? Or you want the previous chapters?
Yes.
Shikani, your voice is coming low. Everyone, this chapter you can do. Previous chapters, this chapter. How many want this chapter? You can raise your hand, right? There is an option of that also in Zoom. Or you can just say, all right, 4 want. We have 6 students in this. So this chapter. All right. In the next class, there will be exam of this chapter. And please revise all of what we did till now. All right. Any doubts in today's class? Any doubts? All right. So this is all for today's class. Take care, guys.
Thank you, sir.
All right.
Thank you.
Thank you,
Yes,
sir.
sir.